Okay, so in this video, we are going to, learn a bit more about your commands of Git, which is a VCS. It stands for Version Control System, and also it is a source code management software, typically. Okay, so we are going to understand those things in here. Now, when you, I have already talked about different types of commands. The basic commands I've talked about, which is like the initialization command and adding your email, as well as adding your SSH key, generating your SSH keys, as well as adding your name in in the records of the Git history. Okay. Now, next, what we are going to learn about this is we are going to understand some of the other commands, which is kind of useful in working with the Git version control system. So typically, in the last video, we have learned that it utilized typically it utilized some of the commands to look at the logs of it. So git log was one of the command in this one, and this is what we have committed in the previous video, right? So in the previous video we have committed this one, and then so typically we have utilized this command to add this file. Now there is two ways to add files. Suppose you have these files in here, which is one file which is .readme.md. The MD stands for in this one is markdown. So you mark it down. So you do not mark it up, you mark it down. So you actually reduce the quality of whatever the text is. Whatever the text is, you reduce its quality. That is the markdown in this one. So that is the MD extension stands for. Okay, so when you talk about markup, which is like HTML, you mark it up like you enhance the quality. But when you are talking about markdown, it is like reducing the quality typically. So that is the basic meaning of marking down, which is the MD in this one. Okay. So that is the basic meaning of MD extension in this one. Now, when you talk about this other commands, right? So some typical few of the other commands you need. So suppose if you are making a directory, okay, making a directory inside your Git repository, which in short we call the Git repo. Okay, so you Git make a directory called like let's say sample Python source code. You made this directory, and you will check it with that list command. Okay, now you see you change directory to again sample. Okay, and then you can utilize one of the wildcards, which is asterisk. You can utilize the wildcard because after sample there is no other directory which is having the sample stuff. So you could use a wildcard to reduce the typing speed as well. So you now go in here, right? Now that is there. Now typically what will happen in here is that I will just make one of very simple Python hello world program in this one. So just for the demonstration purpose and how to utilize Git with your Python projects and everything. Okay, and that's just that. Okay, just that we have utilizing this one. So let's say this is very easy. Right? Anyone can do this one. I'm utilizing it easy because if I'm putting in more complex stuff, students will get lost if I'm just not to the simplest one. Okay, so friend and right. So we have made this file and yeah, we are in. And when we do this one, we got this one file, and when we check the status, it shows that one file is untracked, which is in this one. Okay, so one file is untracked in this one. It checks from this level. It checks from demo git level, right? And we are one level below that, so it is saying that somewhere below there is untracked files. So we go back to the parent directory in this one, and we get into this one in here. And now if you check the git status, then we get to get status that this folder is not tracked in this one, right? So we can add this two ways. We can add it two ways because if we check, if we check, let's say if we check the sample directory, we get that there is one more file in this one. So if we add the folder and what about the other files inside this folder? So that comes into play. Will we add those things? So suppose if you are pretty confident, suppose if you are pretty confident that whatever file changes you have done, you have to just add everything with recursively. You have to add everything with all all the internal directories which is in that repository. So you can utilize a simple command like git add, and then you put an hyphen and you give an capital A in this, right? And it will add, so it will add every file recursively, whatever is in that repository, in that directory, and its subdirectories. Okay, so now you check git status in this one. So now you have this git status in this one, and you see that a new file is in there. The first one is a directory, and another one is the Python file, the sample Python file is there. Now you can add the message, right? Message, the switch for message is hyphen m, and then you just include a message regarding what kind of file you are adding it, and you're sending it over. Okay. So you're sending it over as a simple Python file, so that is what you're sending it to the Git host. So that is what you're getting to the Git host file. Sorry, not the Git host file. That is what you're sending to your Git host where you have registered your account. Okay, so you will write one, include one sample file, one sample Python source code file. You added this one, and to include this in your code book, as always, see code book. To include this in the code book, we have one which we have done in 59 minutes or 1 hour ago. We have done one committed this one, and we have now committed one in this repository as well. To push these commits to your remote Git host, we just utilize this simple command which we have utilized before, is like with your remote variable, which is the origin, and with the branch which you are pushing it to. So this branch is your master branch, so you are pushing it to master branch. Okay. So now when we refresh this one, we will see that we have this folder in here, or directory, whatever you want to call it, and then you have this commit, include one sample Python source code file, and we have this source code in this one simple hello world, and everything else is in this. Now, typically, what I'm going to do next is I will just make one simple project as a demonstration on how to, utilize that simple project and how to develop it step by step along with the Git version control system and how to utilize those things. So it will be like more of like a hands-on way to understand how to utilize those things. And yes, old generations will find it difficult to grasp onto so many things at once, but I believe that younger generation will grasp it faster because even I have grasped a lot of technologies at a very young age, which the other older generation couldn't keep up with the times. Uh, so yeah, I believe that people will be able to understand faster because I'm now recording videos and everything. Before, like I used to learn everything faster with even with the text itself. There were not many videos to begin with at those times. Um, you could add file in here as well, but do not be reliant on the whatever Git host is providing. Okay, do not be reliant on it. Be more reliant on the software which you have in your system, the open source software which you have in your system. So suppose if you want to like check what are the changes again, so you could see the git log in, you do git log in here, and you see that the date and the time is given in here, as well as your email, as well as your name is given in here. Of course, this date and time, it is the fictional date and time. Do remember that even in the previous video, this date and time, this date and time are fictional, because the clock is adjusted according to the place where it is in right now, and other related things. So you could just say that these clock times are fictional. Just believe that for me, that these clock times are fictional. It is not real clock times typically, or something. Yeah. So just believe that. Just believe that for now. Like it's not like we shouldn't just go back to that clock stuff and time and other things. Just that. So yeah. Uh, Apart from this one, let me let me just give you few of the more commands in this one. Okay, let me just give you few of the more commands. So to check branch, in which branch you are in, to get branch -v. So when uh, you utilize this command like get branch -v, you will see that you get this master branch, and then you get this commit of this one. You get this commit of this one, the commit hashed commit of this one, and then you get this message of this one, right? Now this is so we so when you utilize -v switch in branch, it will tell you the last commit of all the branches which you have locally. So we only have one branch in this one, so that is why it is showing that. If you are utilizing git branch only in this one, right? If you're utilizing only git branch in only this one, so it will tell you all the branches which you have locally. Now, suppose if you want to like have multiple branches, right? So suppose if you have multiple branches. So suppose you have done something in master, but now you have to like experiment something, or like test something out, but you do not want to put it in the master branch. You want to like have a copy of the master branch, and like you test things out in the guidelines. And if it is correct, then maybe you get that changes back to the master branch, right? So for that, we can make uh, we can we can make this in this way, as it's so we can make this in this way. Okay, so we can make it in this way. So you have the master branch, which is the main branch in this one. Okay, the master branch is the primary branch in this one. It was for the time when, even like at a start point when this software was started. So master branch is the main branch in this one. It is the central branch in this one. Okay, this one is the central branch in this one. Now, suppose if you want to branch out to some other branches, and like you want to experiment stuff, and you want to like test things out. Okay, now you want to do that. So to utilize that, you utilize the git branch command along with uh, the branch which you want to, the new branch name which you want to like split from the master branch. So if you want to split from the master branch to another branch, and you want to test things out, so you utilize that name in that. So for that, let's say if you want to split out from master, and you want to split out to experiment something, so you can get one of the branch as like a development branch. So for short, the development branch is your dev branch. So dev branch is the short for development branch. So you split out to dev branch. Now, when you check git branch again in this one, you will see that there is a master branch and there is a dev branch. So when you talk about the master branch and the dev branch, The master branch is now selected because it is in the green color, and the dev branch is not selected. So if you want to like switch from the master branch to the dev branch, there is a command called checkout for that. The checkout is the command for that. Now you have to remember in this that if you want to check what are the individual commits in these two branches, you can check again with this command, which is like git branch -b. Okay, git branch. So this will tell you what are the last commits in both of these branches. Now, if you want to check out to dev branch, you can just utilize this command as like git checkout dev. Now, it says that switch to branch dev. Okay, you have switched to branch dev in this one. Right, switch to branch dev. Now, when you check git branch again, it says that the dev branch is selected because the asterisk is beside the dev branch, and also it is in the green color. Please do not be reliant on the color itself in here, because right now I'm showing you it is in the green color, but a different terminal setup or different operating system will show you different thing. Be reliant on the text itself. So if the text is showing an asterisk, so that means that branch is selected right now. Okay. Now, next thing which we have to learn in this one is like we have the same commits in this one. So let's put something else in this in here. So we have something like sample Python source code directory in this one. So let's change directory to that one. Okay, so it's sample and star. That is a aspect in this one. In like in younger years, you could say that it was a star, but now it is not a star. It's the typical word is your asterisk. Okay, sometimes your memory comes in, so that's why. So uh, sample asterisk, and we have this one. So now we have the hello world. So let's do some experiments in this one. Okay, if we do some experiments in this one, so let's utilize the VI editor as usual, and hello world.py. We get this one. Okay, we got this one. And see, suppose if you want to going to modify something. Okay, so we are going to now print something like this is the change. Okay. And we made this change, and we typically save this one as well. Save this one. Now, when you go back to the primary directory where the git was initialized, you will check the git status in this one, and you will see that this is modified in this one. This thing is modified in this one. This thing is modified in this one. So when you see git, this is modified in this one. Uh, you can now add this files again with this command, or you could also do one more thing, which is like much faster and much efficient way. It's like git, you directly commit in this one, and you add one small switch, which is -a, and then -a, which is in lowercase, and then you add the message in this one. Right. Now this does two things in this one. The small a in this represents that it will record all the changes on the file which was previously recorded, all the new changes it will record which was already tracked in the previous in the previous commit. It will track all the changes which was done new. Right. So let me rephrase this one. Okay, let me rephrase this one. So all the files which is tracked in the previous commit, if you have made changes on those particular files, on those particular files, this small a will check those files which has previously tracked and record all the changes, the new changes which you have done right now. And I am now, joining another switch in this one, which is the M switch, which is for the message, and it will do both of those things at the same time. And now you just have to include the message what you want to put, and it will just you know, typically expedite the logging process of whatever software you're developing. So you included one more print statement in Python source code file. Now, typically, okay, one more thing I'll tell you. Typically, when you write a Git message, when you write a Git message, you do not need to use a past tense. You just have to use the typical sentence as giving a command and an order to someone, right? So include one more print statement in Python source code file. Like this is what you have to do. You do not need to. You do not need to. Have it in a past tense or present tense. No, just like an order, or it's just like when you command something, you have to include. You have to. You have to make the message like that. At least the title of that message. And if you're talking about the body of the message, then that that you would that grammar context we can talk about later. But right now, at least you can just go ahead with you know the typical title of the messages, right? So yes, include one more print statement in Python source code file. We have included this one, and when we check get log, okay, so there was one error in this one. Okay, so it will get log, not h, get log, and include one more print statement in source code file. We are getting in this one, right? Now, in here, typically you will see that this head is in dev branch, and the previous one is in the master branch, and obviously this one is also in the master branch, right? So typically the new commit which came into dev branch is this one, which is include one more print statement in Python source code file. However, uh, this commit is not included in the master branch. Is not included in this master branch. So how can we verify this one? So we utilize this command called uh, git branch and hyphen p we type it, and we get that this is the commit of the dev branch, which is include one more print statement in Python source code file, and which one, and the dev branch is actually selected in this one. And in next one, we see that the master branch, which is not selected, it still has the older commit, which is include one sample source code, uh, include one sample Python source code file. So this is it, right? So this is it. Now, so okay, we understand that these are different. Also, if you want to check the individual commits, as in what patch changes was there, we can utilize like git config. No, not config again. That was an error from my side. You will utilize git log and hyphen p. T stands for hyphen p. The p switch stands for what patchwork you have given in this commit. So that T stands for it is the patchwork of the whatever the patchwork you have given for that software, right? So in here you could see that it is the patchwork you have given what you have given. Um, Typically, I have only committed this one. So this is the patchwork which I have given, which is like print. This is the change, and this new line, which is with the plus sign on the left hand side. This is the new line which I have added, and below that there will be the below commit changes will be recorded in this one. That plus B, it represents that it is adding more content, and minus A represents that you know we will go into details of this one later on, but like you can understand like these things were added in this one. Okay? And the details of like what each of these symbols mean, we will discuss this later on if we get some time, or typically it is not required for making projects right now at least. Okay, and when you utilize this command, which is get log -t, to get out of this, it utilizes the it utilizes the same switches or the inputs which VI introduces. So this is having a colon in here, if you can see, as the VI introduces. So you just press Q in this one and you will exit from this one. Okay. So that you have to remember. Right? That you have to remember. Okay. What else? Yes. Next thing what we have to remember in this one. Next thing what we have to remember in this one is, because we have two branches right now. Because we have two branches right now, and those are a bit different commits. Suppose if you want to bring those commits, those patchwork from the development branch to your master branch, what do we have to do? So right now, if you check git status in here, it says that on branch dev, which is the development branch, nothing to commit, working tree is clean. So the working tree is right now, it is clean. Right. Now, if the working tree is clean right now, then we have to and we are in dev branch, and if we check like git status, B, then okay, again this one is again not required for this case. So git branch, I think we will see this one. So the master branch is behind one commit and the development branch is ahead of one commit. Okay, so the master branch is behind one commit and the development branch is ahead of one commit. So if that is the case, if that is the scenario in this one, then what we have to do is we have to first check out to the master branch in here. Right now we are in the development branch. So git check out not development branch but master branch. Okay. So when we check out to the master branch, when we now check again the what is the branch states in right now in here. So we see that we have the master branch which is behind one commit and a development branch which is ahead one. Remember that we have made the development branch to experiment something and let's say to figure out something, whether something will work or not. Typically, a development branch is your unstable branch, and the master branch, which is the main branch, it is the stable branch. Okay, so the unstable branch is the development branch, and the master branch is the stable branch. So when we talk about the master branch, it is the production branch. Typically, it is the production branch, and something if something fails in the master branch, typically it is not uh, you know good that something breaks in the master branch itself. That is why sometimes we utilize some other stuff in the production branch. Some balance and checks are there in the master branch hooked with the continuous integration as well as the continuous delivery. Those things are hooked with those things. But we will go into those things later on. Okay. So typically that is required in this thing. Required in this thing. Yes. So now if you want to bring something from the development branch, which we have tested that it is working correctly, compiling correctly, or have no errors, then we will now merge the development branch. We will merge the development branch, which is like the command is merge. So git merge is the command, and git merge. And what we have to merge is we have to merge your development branch. So git merge and dev. So because we are in the master branch, the development branch will be merged, and we are mentioning the development branch name, which is dev in here. Okay. So if you see in here, it is utilizing the pass forward merge, and it has changed one file, inserted one more line, and the total total changes are in here, and it is using the pass forward merge in this one. There are different ways to merge in this one, like rebasing is there, pass forwarding is there. There are different ways of merging in there, but typically the default one is the pass forward merge. So what you do is like you whatever the commits are, which is done afterwards, it is included in the master branch, and which was done before also, like it is also like adjusted between the master branch as well. So typically, the development branch will have the most priority compared to the master branch, because the development branch was experimenting with few of the things and master branch was going slower. So the development branch will always have your priority. That is why it is fast forward mode. Um, However, if the master branch is ahead, then typically issues arrive in this one. If the master branch is ahead, then the issues arise, and then the fast forward merge will not work. In those cases, we have to utilize different kind of merges. In those kind of cases, different kind of merges will be required. Typically, the master branch will only get the refined stuff. The master branch or the main branch will only get the refined stuff, not your experimental stuff. Typically. Okay. Okay. Uh, we have to remember is that once all the tests and debugs have happened, sometimes what happens is that even in the master branch something fails or something breaks, right? And this usually happens in kind of a rapid development, or sometimes it happens due to some unforeseen circumstances that something breaks in the master branch itself, right? So for those cases, what we have is called we have a branch name called hotfix. So we have a branch name called hotfix. So if something breaks in the master branch itself due to some unforeseen circumstances, so for that we have to make a one branch, and we split it out of the master branch itself, and we name it as hotfix. And we check out the hotfix, and in the hotfix what happens as that whatever we fix in the hotfix, we fix it very quickly and very accurately. So that is the hotfix in this one, and then we merge it back to the master because something has broken in the master branch. So that is a very bad situation typically. So that is why the hotfix branch is there. Now, check out to if you check out to development branch. Now, usually after a development branch, whatever things have been developed, we have something called a debug branch, because in development branch usually bugs comes in. So for that we have the development branch. You check out. So all the bugs could be in the development branch itself or in the feature branch itself. So depending on the project organization, whoever is the development operators in there, they can adjust it accordingly. But if suppose if the project is not that much big, then we have a debug branch which branches out of your development branch. Okay. Now, typically, if you check out a debug branch and it doesn't have if it doesn't have that branch, then you have to make that branch. So if you want to split your development branch to a debug branch, so you do one thing: git uh, branch, and then there will be what? There will be debug, and debug will be with debug. Okay, so basically you remove the bugs and you remove the bugs. So after the bugs are removed, right, we will merge it back to the development branch, and then we will merge that debug branch to your master branch after all the debugging is okay. So this is this is this setup is still for a medium scale uh, project. Okay, this is still a medium scale project. So if you check like a branch, if it goes into this one, So we have the debug branch, we have the hotfix branch, and we have the master branch in this one, right? So debug branch, so whatever errors that comes in your development branch, it will go to the debug, and from the debug it will merge back to the master. And suppose in some rare cases and unforeseen circumstances, the master branch got something broken during the merge time, and the CI and the continuous integration and continuous delivery highlights it that something is broken in this one. Then we go to the hotfix, and in hotfix we fix it very accurately and very fast, right? Then of course, when we have your development branch in this one, where you have something in a development branch, the development branch will typically will branch out to some feature branch. Okay, this is another layer of checking in this one. This is another layer of checking in this one. So we have something called a feature branch. So we are in a development branch right now. So we branch out from the development branch to your feature branch. So let's say we name the feature branch as feature. Okay. So then we say as let's see what is the status of all the branches. We have now the master branch, we have the hotfix, we have the feature branch, and we have the dev branch, and we have the debug, right? So when you talk about the feature branch, all the bugs and the debuggings, everything happens in the feature branch itself, right? And then we merge to the development branch, and during that merge, if some error occurs, then we go to debug branch, and from the debug branch we merge back to master branch, and if the master branch or unforeseen circumstances it breaks, then we go to hotfix and we fix it very quickly and very accurately, and then merge back it to your master branch, right? So feature branch, right? Get check out. So now we have the feature branch again. So all in all, this is how your branching system works. This is how the merging works, and I think most typically for the students, which is it is recommended for to utilize this one as a more definite way to like establish themselves in a proper coding environment. This much is only required. Apart from that, beyond this, it goes to like beyond 4 year of software engineering, and it goes to masters and everything else. So yeah, just like going ahead with this one. Going ahead with this one only. This is as much as you require to learn right now. Okay. Thank you for being here, and hopefully you have learned something in this one. All right. One more thing we have missed, which is like pushing all the branches to your remote host. So suppose you have a lot of branches, right? So like we have a lot of branches in here. Get branch. We have a lot of branches in this one. Right. So we have only pushed in, let's see, what branches we have in here in Codebug. We have the master branch, any other branch? We don't have another branch. So suppose if you want to push in your development branch, so we utilize get push, and the variable of the remote name is origin, and then we have the development branch which is dev. Okay. And we utilize this command, and we are now putting it to the remote repository, which is put in the git host, which is your Codebug. Let's see what happens now. Okay, so enumerating object 7 done, counting object delta compression is there, and writing object is there. And in the remote, create a pull request for dev, and this is have they have created a pull request for dev. Internally, they have done that. Okay, internally, they have done that, and then the new branch is now in here is the dev. The dev branch is now pushed there. Now, if you refresh in here, so we have two branches in here. The master is the default branch, and the development branch is the next one, right? And in here also you can see that this is the two branches in this. Alright, so this is it. So the second commit was done 32 minutes ago. Now suppose if you want to push all the branches at one go. Suppose if you want to push all the branches in one go. So for that, what you have to do is you have to use git push. You have to mention the remote name obviously, and then you have to utilize this switch which is on. Git push origin on, double hyphen and on. And if you do this one, then all the branches which you have locally, it will be pushed to the remote repository. Right. So now all the branches are pushed to the remote repository, which is your codebook, which is hosted in the codebook, and then you have all the repositories in here. Right. So now we have 5 branches in total, 3 commits, 0 tags are there, and 1.8 kilobits are there. So tag systems I could also like tell you more about, but again, tag systems are not required unless until you are maintaining the software and not just making a prototype. Okay, so tag systems are not required. Now we have understood all these things. Right? How much time we have recorded? 41 minutes. We have recorded for 41 minutes. Right. So we have recorded for 41 minutes, and this is enough recording for now. I don't know who will actually utilize these things, but this is the best way to do coding stuff.